Hi guys, today we are going to discuss about the topic structure of nephron. Okay, what is nephron, where it is located, what are the functions of the nephron. Okay, we are going to discuss about these functions in this chapter. So, if come to the structure of nephron, nephron is structural unit and functional unit of the kidney okay. So, structurally nephron has two parts. Nephron has two parts. Okay. One is glomerulus and the next one is renal tubule. Okay. These are the two parts comes under nephron. If come to the glomerular, what is glomerular? It is the blood vessel, the fine branch of the renal artery, the tiny branch of the renal artery, So, renal artery is what? Renal artery nothing but it is carry the oxygenated blood and as well it is carry the urea from the heart. Okay. It is divided from the systemic aorta. This is heart. From the heart, the systemic aorta further divided into renal artery. Systemic aorta further divided into renal artery. Artery further divided into, this is artery, assume this is artery. Artery further divided into arterial, arterial further divided into capillaries, This is the order. What is glomerulus? What is glomerular? Glomerular is the capillary network. This is the artery. This is arterial. This is capillary. So, glomerular is the capillary network. Where it is located? Glomerular as it is capillary network. Where it is located? In the kidney, in the nephron. Okay. Capillary is nothing but the divided from the arterial. Arterial nothing but divided from the artery, which is renal artery. So, renal artery, this is the renal artery as three layers: tunica externa, tunica media, and tunica interna, Okay. These three layers has renal artery. They do not allow any filter because of tunica media is the muscular chamber. Okay. In that way, renal artery further divided into arteriole. Renal artery further divided into arteriole. Okay. Arteriole. As we said, arteriole. Okay. Arteriole further divide into capillaries. Okay, capillary. This is capillary. Okay, this is capillary. Where it is coming from? From heart. Renal artery coming from contact with heart. Okay, this is the capillary. Glomerular is the capillary network. Okay, this is the capillary. If come to the kidney, this arteriole, we can call it as efferent arteriole. Efferent arteriole. Arteriole. Efferent arteriole. This capillary network further making the network into like this. Okay, where the capillary end, there is a veins are started, but here capillary end again arteriole start. This is arteriole. Okay, this is efferent arteriole, this is capillary network, and this is efferent arteriole. Okay, capillary formed as a network here, this is efferent arteriole, efferent arteriole, efferent arteriole. So, efferent arteriole, to make efferent arteriole here after formation of capillary network here. This is the capillary network in the nephron, in the part of nephron, we can call it as glomerulus. Glomerulus. This is the fine branch of capillary network. Okay, glomerulus itself do not to make the nephron. There is a renal tubule. This is the circulatory part. If come to the renal tubule, okay, yes, if come to the renal tubule, this is the capillary network, this is the Bowman's capsule, which is the tissue of the epithelial tissue. The tissue of the epithelial tissue we can call of the Bowman's capsule. This is the tube which is made from the epithelial tissue. Bowman's capsule and glomerulus network together we can call Malpighian tube, Malpighian body, Malpighian body, Malpighian body. Further, this is the tube going to extend to make the nephron. Okay, nephron has two parts. One part is glomerular, which is how it is originate, and one part is renal tubule, which is the formation of epithelial tissue. This is about the brief introduction about nephron, which is the structural and functional unit of the kidney. Structurally, it has two parts. Functionally, it makes the urine filtration. Okay, it is the fine like structure which is nearly 1 million in the kidney. Each kidney has 1 million of the nephron. Okay, two kidneys are 2 millions, mean 20 lakhs nephrons are there in human body, human kidney. Okay, yeah, going to discuss about detail about nephron. Okay, yes. Each kidney nearly 1 million of the nephron. Each kidney nearly 1 million. It has structure and it has function. It has own structure, it has own function. Each nephron has two parts, as we said, glomerulus and a renal tubule. Just look into this. It is the nephron, glomerular capillary network, okay, glomerular, and as well renal tubule, which is made from the epithelial tissue. Okay, cool. Yes, and the location of the nephron. Okay. Glomerular is the capillary network, as we said. Okay. It is the fine branch of the renal artery. Fine branch of the renal artery. Okay. Yeah. The blood from the glomerulus carried away by efferent arteriole, as we said, right. This is the glomerular, this is the Bowman's capsule. Glomerular enter into this to form exit out. Enter part efferent arteriole, exit part efferent arteriole, efferent arteriole. Enter part they can carry into the Bowman's capsule blood, and exit part they carry out the blood. The urea filter here, this is the mechanism. Does it mean they carried out only blood? Efferent arteriole they carry out only blood. Efferent arteriole they carry in blood and as well urea. Efferent arteriole. Efferent arteriole they carry out only blood. Okay. Yeah. And yeah, the renal tubules begin with double wall cup like structure. Cup like structure, that is Bowman's capsule. Cup like structure, that is Bowman's capsule. Okay. Encloses with glomerulus. Capsule enclosed with glomerulus. Enclosed. Okay. This is efferent arteriole. This is efferent arteriole. Okay. Yeah, this is Bowman's capsule. Okay. It is cup like structure covered glomerular. Okay. This is renal tubule. Further going to discuss about renal tubule. Yeah, glomerulus along with Bowman's capsule called Malpighian body. Glomerulus along with Bowman's capsule called Malpighian body. This may ask in the exam. Okay. What is Malpighian body? Okay. Yep. And yeah, the tubule continues further to form high call network proximal convoluted tube, PCT. Yeah, we are going to discuss about nephron. Okay. Nephron. Nephron. Okay. What is nephron? Okay. As we discussed, this is efferent arteriole. Okay. Efferent arteriole. Arteriole. What is arteriole first? Arteriole nothing but it as like their arterial walls as endothelial cells, guys. They can carry the blood. They can carry the blood. They can carry the blood. It as endothelial cells. Endothelial cells nothing but they are the squamous epithelial tissue. Endothelial cells. Endothelial cells. Nothing but it is modified epithelial tissue. What kind of epithelial tissue? Squamous epithelial tissue. Squamous epithelial tissue. Squamous epithelial tissue. What is the function of the squamous epithelial tissue? To involve the function of squamous epithelial tissue to involve involves in the diffusion and in the filtration. So in the filtration there is a function, right? Here filter is required, right? So squamous epithelial tissue in the endothelial tissue. This is the capillary, blood capillary, which is renal artery, from renal artery. Okay, renal artery further divided into arterial. Okay, this is the capillary as this mechanism involved in the filtration. Mechanism nothing but there is a modified squamous epithelial cells in the wall of capillary network. Capillaries, endothelial cells. Okay, yeah. This is the efferent arteriole make the fine branch of the capillary network, which is glomerular arteriole. Efferent arteriole make capillary network. This is the network. This is the capillary network. Yeah, capillary like this, convoluted capillary network, and this is exit as efferent arteriole. Efferent arteriole. Efferent arteriole, capillary network, efferent arteriole. This network we can call glomerular or glomerulus. Here, are you clear? There is a question, guys. There is a question. If the artery further divide into arteriole, after that this arteriole further divide into capillary, they can carry the blood throughout this network, carry the blood. This capillary finally reach the blood tissue. Right? Artery always carry oxygenated blood. So this oxygenated blood finally reach the tissue. Capillary is the functional part for the give the oxygen into the tissue or organ. Okay? Yes. Finally tissue used oxygen in the metabolic mechanism. After that tissue produce carbon dioxide, blood, deoxygenated blood. Deoxygenated blood, who can take away deoxygenated blood from the tissue? Starting with capillary, here capillary. This capillary further divide into venule, here arteriole, right? Arteriole. Artery further divide into arteriole. Capillary further make to venule. Venule further to make vein. This is the mechanism of the blood vessel, which they can give the blood into the tissue and take the blood from the tissue. This is the network. Here just look into this. Artery end with capillary. Vein start with capillary. Does it mean everywhere the artery further divide into arteriole and capillaries with end, and vein is started with capillary? This is the mechanism everywhere. But look into this. Efferent arteriole to form capillary, after capillary again to form arteriole. Arteriole after formation, arteriole here formation, vein started, but here arteriole, efferent arteriole after formation capillary again to start efferent arteriole. Just look into this. The primary function of this artery after capillary, the primary function here is to give the oxygen to the tissue. But here the primary function of oxygen is not yet over. Capillary network to form for the purpose of filtration. Capillary network of the glomerular capillary network of the glomerular, the function is filtration only, not give the oxygen itself here. The function not yet over, the prime function of the arterial or capillary is not yet over here. Here the function of the capillary network to give the filter of the urea. This is about the glomerular, which is circulatory part of the nephron. What about renal part of the nephron? We are going to discuss about renal part of the nephron. Okay? Yes. So, the blood enter here, oxygenated blood enter here into the capillary network. Okay? From the arterial capillary network, the blood exit. But what about urea? Urea filter, there is a need of the structure, which is cup-like structure, that is the structure we can call Bowman's capsule. Bowman's capsule. This is the Bowman's capsule double layer wall, okay, and Bowman's capsule further extended highly convoluted tube, okay, okay, like this, highly convoluted tube, like this. Like this. This is Bowman's capsule. Nearby cup, there is a part which is near mean proximal convoluted tube. Proximal convoluted tube. We can call it as PCT. And where it is distance D, DCT, distal convoluted tube, distal mean, convoluted mean to coil, mean there is a some structure which is extend, okay. Yep, up to here clear. Distal convoluted tube and proximal convoluted tube. This is the hairpin like structure, Henle loop, and this is the finally take the fluid, final part, it is collecting duct, collecting duct, CT, collecting duct. Okay, this is all over about nephron. Okay, yeah, here just look into this. It is the nephron functional unit structure. This is the structure. It is also functional unit of the kidney. What is the function? Main function to filter the urea fluids. Okay, to maintain osmoregularity. If the fluid come from capillary network into the Bowman's capsule, okay, there need a filter mechanism. Of course, which is fine branch of the capillary network, there is a endothelial tissue, capillary network here, fine branch of the capillary network, Just look into this, guys. Cool. Yeah. Yeah. Fine branch of the capillary network. Capillary network nothing but capillary made up of with endothelial cells, capillary walls made up of with endothelial cells. Endothelial cells involved in the filter. Okay? Yes. Here capillary network. Nothing but it is the capillary. This is capillary. Capillary enter the what like fluid, urea fluid. Capillary network has endothelial cells like this. Endothelial cells has certain basement membrane, and Bowman's capsule also made up of with epithelial tissue, guys, most important. Where there is a filter going to take place, there is a epithelial tissue. This is squamous epithelial tissue. Squamous epithelial tissue. Squamous epithelial tissue. Here the filter is going to take place from capillary network into the Bowman's capsule. Mean it can cross 3 layers. 3 layers. Okay, it can cross 3 layers. Okay. What are the 3 layers? Capillary network 1 layer and base membrane, and this is the Bowman's capsule wall, squamous epithelial, Bowman's wall, which is squamous epithelial tissue. Squamous epithelial tissue. So, renal tubule made from the epithelial tissue. It is the tube which is made from the tissue. Okay? We are going to discuss where the tissues are going to take place in the epithelial tissue. Okay? Yes. This is the efferent arteriole. This is the capillary network, efferent arteriole network. Okay? Efferent arteriole. Efferent arteriole. Efferent arteriole, efferent arteriole. Okay? This is glomerulus, and this is one part of the kidney, and the next part is renal tubule, renal tubule, renal tubule. This is nephron. This is nephron, guys. Here, like epithelial tissue in the Bowman's capsule, squamous epithelial tissue, guys. Squamous. Squamous epithelial tissue. Okay? Here DCT. DCT as cuboidal epithelial tissue, guys. Cuboidal. Cuboidal epithelial tissue. Guys, here look into this. This is the proximal convoluted tube, PCT. Proximal convoluted tube. It is a nearby the filtration. Nearby the filtration, which is solute enter into this. If the solute enter into this, it is can be reabsorbed here. There is a reabsorption going to take place, this PCT part. So, this cuboidal epithelial tissue modified, this is the cube-like structure, cuboidal epithelial tissue, they are modified into, this is the cuboidal, they are modified into brush border cuboidal to increase the surface area. This is the brush border finger like structure, we can call it is like, this is the finger like structure is the cytoplasm extravert, like cytoplasm to exit to form the finger like structure. Okay. This is the finger like structure projections, cytoplasm projections called brush border cuboidal to increase the surface area nearby the filtration, PCT, proximal convoluted tube. If come to the Henle loop, this is made up of with squamous epithelial tissue. Squamous epithelial tissue. If come to the DCT, distal convoluted tube, it is made up of with cuboidal epithelial tissue. This is the collecting duct. Finally, collect the urine. Okay. This is all over about the nephron. We are going to discuss about deep from the slides. Okay. Yes. So, if come to the location, nephrons are two types based on their location. Okay. We are going to discuss about it. Okay. Based on nephron location of the nephron, based on their location, nephron. Okay. Yeah, where it is located, this primary unit, functional unit, microscopic unit, where it is located? Yeah, just look into this. This is kidney. Kidney has two parts, two regions. This is kidney, two regions. One is cortex. One is medulla. This is the medulla. Medullary region has set projections, we can call medullary nephrons. Medullary nephrons. Medullary pyramids. Renal artery, they enter here into the medullary pyramids. It can be converted into the branches. Renal artery further converted into the branches. Renal artery. This branch further divided into arterial and capillary network, and they exit arterial, efferent arterial. This is about renal artery, and this is the Malpighian body, this is the glomerular. where there is a renal tubule, that is excretory part, renal tubule, excretory part, Bowman's capsule, and yeah, I'll come again, just a minute, guys. Okay, this is the pyramid, renal pyramid. Okay, yep. Renal artery further extended from the columna betin, further divided into glomerular here. This is the glomerular network and efferent arterial and efferent arterial. This is glomerular, and if come to this renal tubule, Bowman's capsule, this is Bowman's capsule, PCT, DCT, and Henle loop, and collecting duct. This is what about nephron. The location of the nephron. In the cortex part somewhat, cortex part and medullary part, there is a question, which part of the nephron, comes under medullary part, Here a question about Neet. A, glomerular plus PCT. B, PCT plus DCT. C, DCT plus Henle loop. D, like Henle loop with collecting duct. Which part of the nephron comes under medullary pyramid? This is the question based on the location of the nephron. You may not find in NCERT, but it is the previous year question. Does it mean you have to think, you have to analyze the observation question? While you are reading about nephron, you have to think what is the nephron, where it is located. This is the mandatory, you guys to make it answer. Okay? Yeah, here look into this Henle loop is comes under nephron, and as well collecting duct. This option D is correct. Henle loop and collecting duct based on the location of the nephron. Okay? Yes, and we know that is some nephrons are cortex region, some nephrons are medullary region. Cortex region nephron, cortical nephrons. Okay. Medullary region nephrons are juxtamedullary nephrons. Yeah, just look into this. If cortical nephrons, this Henle loop not comes under that much of elongated into the medullary region. Okay, if this is medullary pyramid, okay, yeah, we are going to discuss in the slide, guys. Okay, yeah, based on nephron there are two types: cortical nephrons. The majority of nephrons, 85% guys, are the cortical nephrons, majority of the nephrons. Okay, loop of Henle is too short. Loop of Henle is too short. Extends only very little into the medulla. Extend only little, very little, not about absent. Confused, don't confuse, they might give you chance like medullary, like cortical nephrons, there is a absence of like Henle loop into the medullary region. Okay, yep. Cortical nephrons and juxtamedullary nephrons. Juxta mean near, juxta near, juxta mean near, where the nephrons mean near of the medulla. Juxtary medullary nephrons or the loop of Henle is very deep. Just look into this. This part, this dark part is medulla. Medulla. This part is cortex. Cortex light part. PCT. PCT there in the cortex region only. Bowman's capsule also there in the cortex region only. DCT also cortex region only. Henle loop itself in the medullary part. Okay, juxtamedullary Henle loop, it is very high, deep in the medulla. Cortex region very low, deep. They are just enter into the medullary part. Okay, cool. This is about cortical nephrons and medullary nephrons. Okay, yes. Here we are going to discuss the difference between them. Juxtamedullary nephrons only 15%, guys, only 15%. These are the cortical nephrons are the high amount, 85%. 85%. Does it mean medullary interstitial fluid involved in the like osmolarity? Okay, they are more regulated. Okay, yep. Cortical nephron not that much of. Glomeruli close to the margin of the cortex itself, we know. Glomerular is outer cortex. Outer cortex. Okay, they are large in size. Yeah, obviously. Henle loop is very elongated, right? Largest, obviously. They are smaller size. Henle loop, it is reduced. Okay, yeah. Loop of Henle very long and extended into the deep medulla. Henle loop is very short. It is little into the medulla. Okay, yeah. They control the plasma volume because of medullary interstitial fluid involved in the regulation. This is the plasma volume is when water control, water. Okay, plasma control. Here there is another point. Vasa recta highly developed covered Henle loop. Here vasa recta absent or highly reduced. Vasa recta absent or highly reduced. Okay, this is what is vasa recta. What is vasa recta? Okay, it is thoda tough, right? What is vasa recta? Okay, like vasa recta nothing but vasa recta is what? Okay, yeah. This is Bowman's capsule. This is efferent arteriole, further divided into efferent arteriole. I will give you colorful. Okay, like this is Bowman's capsule, renal tubule, PCT, DCT. Okay, yeah. where there is a glomerular extent, efferent arteriole, turn into the glomerular, efferent arteriole, and the prime function of the glomerular mean the prime function of the arteriole to carry the blood into the tissue, right, capillary. Here the prime function is not over it, filter only going to take place. The remaining again to form arteriole, efferent arteriole, efferent arteriole, efferent arteriole, efferent arteriole, efferent arteriole. This arteriole again to form capillary network, again to form capillary network. This is the capillary network they covered Henle loop to give the oxygen into the nephron tissue. This is the capillary network, covered Henle loop to give the oxygen into nephron tissue, called vasa recta, This is all about vasa recta, cortical nephron and medullary nephron. Okay, this is what. Okay, efferent arteriole emerging into the glomerulus to form fine capillary network around this. Okay, the Malpighian capsule, PCT, DCT situated in the cortical region, and a minute vessel of the network runs parallel to the Henle loop, forming a U-shaped vasa recta absent, highly reduced in the cortical nephron. Okay guys, cool. This is about nephron. We are going to discuss the formation of urine in the coming class. Stay tuned. This is Neet World. Thank you.